If you're in the tech world, you've definitely heard about the system design interview. You've probably even dreaded it. It's this huge, open-ended, high-stakes chat that often stands between you and a dream job. But what if I told you there's a method to the madness? That there's actually a clear framework that can turn this whole ordeal into a chance to really show what you can do? Let's break it all down.
Okay, picture this. You're in the interview, and they just dropped this on you. So, how would you design YouTube? You've got, 45 minutes to come up with a plan for a system that took thousands of engineers years to build? The silence in that room can feel pretty heavy. It sounds completely impossible, right?
And hey, you're not wrong to feel that way. Even system design experts like Alex Su say it. These questions are meant to be intimidating. They're huge, they're vague on purpose, and there is no single right answer. So if it's not a test to see if you've memorized YouTube's architecture, what on earth are they actually looking for?
And that, right there, is the secret. The goal isn't to magically produce a perfect, ready-to-go blueprint of YouTube. Not at all. The real goal is to show them how you think. There's a way through this maze, and it's all about demonstrating how you tackle a giant fuzzy problem and bring structure to it.
So let's just get this straight. Nobody expects you to have the right answer. What they want to see is your process. How do you deal with ambiguity? How do you ask questions to narrow things down? How do you organize your thoughts? It's really more of a collaborative conversation than it is an exam.
So, how do you lead that conversation? Well, you use a framework, a solid, repeatable strategy that gives you a roadmap to follow when things get fuzzy. You can think of it as your 4-step battle plan.
Here it is. Step 1, you figure out the actual problem by asking a ton of clarifying questions. This is super important. It stops you from building the wrong thing. Step 2, you sketch out a high-level design to make sure you and the interviewer are on the same page. Step 3, you dive deep into 1 or 2 specific parts, showing off your technical chops. And finally, Step 4, you wrap things up by talking about trade-offs and what you might do next, which shows you can think about the future.
All right, theory's great, but let's actually see how this works. We're going to use this exact framework to build a system from scratch, and we'll scale it all the way from 1 user to millions. And along the way, we're going to uncover the core ideas behind almost every large-scale system out there.
So, let's start at the very beginning. Day 1. We have a single server. Your web app, your database, literally everything is running on this one machine. It's simple, it's easy to manage, and honestly, it's perfect when you're just getting started. But then you get that problem that every founder dreams of: success. Your app goes viral, traffic is through the roof, and that one little server is just completely overwhelmed. Now users are seeing crazy slow load times, or even worse, your site is just down. So what's the move?
You basically got 2 choices. You can scale up, which just means making your one server bigger and more powerful, more CPU, more RAM. That's called vertical scaling. But you'll hit a wall pretty fast. The real answer for massive growth is to scale out, or what we call horizontal scaling. You just add more servers.
Okay, but if you have a bunch of servers, how do you decide which one gets the next request? That's where a load balancer comes in. Think of it like a traffic cop for your website, or maybe like the host at a really busy restaurant. It sees the incoming traffic and directs it to the servers that have capacity. And the best part, if one of your servers fails, the load balancer just stops sending traffic there. Bam! You've just built in redundancy.
Awesome. So our web servers can handle all the traffic we throw at them. But all we've really done is move the bottleneck. Now all of those web servers are hitting our one single database, and it is starting to crumble under the pressure of all those reads and writes.
The classic solution here is something called database replication. You set up one primary database that handles all the new information being written. Then you create multiple replica databases that are just copies of the primary. All the requests to read data go to the replicas. This spreads the workload out and gives you a massive performance boost.
So now our system is scalable and it's reliable. But we've got a new problem: speed. Users in, say, Europe are complaining that the site feels slow. And even with our fancy database setup, some requests are just taking too long. So, how do we make things feel fast?
Your first go-to for speed is a cache. The easiest way to think about a cache is as your system's short-term memory. It's a layer of super fast storage that holds on to frequently accessed data. You know, when you open up Instagram, the first few posts on your feed load instantly. That's almost certainly because they were pulled from a cache, not the main database, saving a ton of time.
The second big tool for speed is a content delivery network, or CDN. This is how you tackle that global latency problem. A CDN is basically a huge network of servers distributed all over the world, and they all store copies of your static files. Images, videos, things that don't change often. So when a user in Tokyo requests a photo, they get it from a server in Tokyo, not from your main server back in the US. It's a game changer for load times.
Okay, so let's pause for a second. As we've gone on this journey from one server to this global application, we've actually stumbled upon some of the most important principles of designing scalable systems. Let's just lay them out clearly.
Here it is. This is basically your cheat sheet. You want to keep your web server stateless, meaning any server can handle any request. You need redundancy everywhere. You should cache aggressively. Use a CDN for static stuff. For truly huge databases, you can do something called sharding, which is like splitting your database into smaller chunks. Decouple your different functions into their own services. And of course, monitor everything all the time.
Now, it's really easy to look at this list and just think of it as a checklist to get through an interview. But in reality, these ideas are so much bigger than that. And that's the real takeaway here. Every single major service you use every day, Netflix, Google, Amazon, you name it, is built on these exact same principles. Load balancing, CDNs, caching, replication. This isn't just some abstract theory. This is literally the blueprint for how the modern internet is built.
So understanding these building blocks does way more than just get you ready for an interview. It gives you the vocabulary and the mental models to think about and design your own robust, scalable software. The next time you're staring down a huge, intimidating problem, you'll have a roadmap. You'll know the patterns. So really, the only question left is, what are you going to design?